Hello students, we are going to see today your 8 number practical sheet, that is section of solid. So previously we have seen projection of solid. So what is the basic difference between the projection of solid and section of solid is that in the statement given to you, they will give you the which type of solid is that. So whether it is a pyramid, prism, or a cylinder, or a cone, then they will give you a cutting plane or a sectional plane, which is with respect to HP or with respect to VP. So in the figure A, it is in HP. So in front you, the section plane is used, and we are assuming that the upper part of this cone is cut, and the observer is looking from the top, and you will get a sectional top view. So uh, in the second figure, that is figure number B, here in the statement they will give you the section plane is with respect to VP. So we are going to use the section plane in the top view, and we are assuming that after using this section plane, this part of the portion of the solid is removed, and observer is looking from this end, and you will get a sectional front view. Likewise, an example is given in this. A square pyramid example is this. So a sectional plane is used, XY plane. It is of 45 degree with respect to HP, and we are imagining that the upper portion of this pyramid going to cut, and the observer will look from the top view, and you will get a sectional top view here. And the another is a true shape. The actual size of the section will be normal to the section plane as shown in this. So this is an apparent shape of the section, so and this is a true shape of the section. Okay, now in the assignment number or sheet number 8, we are going to solve 3 problems. One problem is on pyramid, then second problem is on prism, third problem is on solid of revolution type. Okay, that is cone. We are going to use cone. So let's begin with the first problem is a square pyramid. Okay, so given a solid is a square pyramid. Okay, and its dimension given is 40 mm side and 65 mm long means the height of the pyramid is 65 mm, as its base on the HP, so it is resting on the HP XY line. Then all the edges of the base equally inclined to VP. So the edges of the pyramid should be equally inclined to VP. So while drawing the top view, you have to draw the top view, that is 45 degree. Okay, then it is cut by a section plane. So section plane is given perpendicular to VP, and it is inclined to HP. So we are going to use this section plane in the front view, and the bisecting the axis. So it is at the center of this height 65 mm. So it might be a 32.5. At that you have to take 45-degree angle, and you have to cut the solid. Okay, now they have asked you to draw a sectional top view, sectional side view, and true shape of the section. Okay, so let's begin with the problem. First of all, you have to draw a reference line, that is XY line, and as it is mentioned that it is equally inclined, and all the edges of the base is equally inclined to VP. So your edges should be in this way. Okay, 45-degree angle. Okay, so the top view of your pyramid, square pyramid, should be in this way, that is a 45. So it is equally inclined to VP. So for this, draw a 45-degree line and use your drafter, or consider a point here, and then normal to this 45-degree, you have to draw two lines, that is of 40 mm 40 mm, and then join it. Or otherwise you can take vertical line and horizontal line, and you will in the side, I think here is given, plane is given here. So you have to draw a square here sidewise 40 by 40 in this way. Okay, other method I am showing you. Then join this by the diagonal in this way. Join the diagonals. Then take your compass from this to this. Take your uh, means a dimension from the center of this diagonal to this. Okay, and then plot over here. You will get a 45-degree line. Okay, so this is a other method to draw this, if you are not going to use the drafter. Now, okay, so now give the numbering or naming A, B, C and D, and center point or the apex point as O. Okay, in this way, and then project this towards front view. Okay, front view. So height given is a 65 mm, so it is resting on HP, so you have to start with the XY line. Okay, so it should base should be resting on the XY line. Okay, then okay, so all these lines, this and this should be dark because it's the edges of your square pyramid. Okay, and then transfer the points A dash, B dash, D dash and C dash, and this should be O dash. Okay, now the section plane is bisecting the axis, so it should be at 32.5 from this. Okay, and 45-degree angle. So take 32.5 and then draw the 45-degree angle line. So in this way. Okay, so where it cuts here, okay, it cuts here and it cuts here, so section plane cutting at the edges in the here and here. Okay, so project that edges, okay, downwards. Okay, now you will get this point here. So this edge where it cuts A dash to O dash, A dash to O dash, you will get a point. Then C dash to O dash, you will get a point. But at B dash D dash where it cuts, we because it is at the center, we can't get the point. So for that you have to take a horizontal line in this way. Okay, and then you have to project downward. Okay, project downward. So from this when where this projection comes towards the center of this, take your compass and draw this circle over. Then this will be your D point, this will be your B point. Okay, you will get in this way, and then join this. Okay, so this will complete your sectional top view. Okay, so 1 2 3 and 4, and here also you can give 1 dash, 2 dash, 3 dash, 2 dash, 4 dash and 3 dash in this way. Okay, so and draw hatching line over here. So the portion below this section plane should be dark compared, and this should be faint. Upper portion of the section plane should be faint, and all this portion should be dark in this way. Okay, and then use a hatching line to show the sections in this way. Okay, so to get the true shape, okay, true shape of your section, so I will complete first and then I will explain this. Okay, in this way you have to use a hatching line. Okay, to get this true shape of section, project your lines, projection lines, take your projection lines from this section plane normal to this section plane, so 90-degree in this way, 90-degree, 90-degree. Okay, then draw a line parallel to this section plane, parallel to this section plane. Okay, in this way I will show you. In this way, it is not shown in this, but a straight line, it should be a straight line. After drawing this line, Okay, uh, you will get the first point is 1 dash and 3 dash point. It is on the edges of the solid, so you will get this directly, this 1 1 1 and 3 1. Okay, to get this 2 1 and 4 1, you have to take the reference from this sectional top view. So take your compass and this O as a center, take the distance O to 2, then keep that same distance over this line and plot this 2 1. Okay, then O to 4, same distance will be here, and then join this. So this will your actual section true shape sectional view. Okay, true shape sectional view. Now for the side view. Okay, now for the side view, draw x1 y1 line. Okay, take some distance 10 to 15 mm and draw this x1 y1 line, and then project these points. Okay, shift these points over here. First a dash, c dash, then double dash. You can use double dash also. Okay, for side view. Okay, in this way, first draw the actual solid, that is a square pyramid. Okay, in the side view, use double dash for that, and draw it faint first, and then you have to use dark one. Okay, then project this points 1 dash, 2 dash, 3 dash, 4 dash points towards this side view. Okay, how to project it? So 1 dash should come at this A point, so it should be cutting at A point, intersection point. You will get this 1 double dash. Then 2 point and 4 point will be at the edges, that is B and D. So you will get here B and D, you will get 2 dash, double dash, and 4 double dash, and this should be at the center because at C is here, so you will get here 3 double dash. Okay, in this way you have to join this first, and this portion should be dark, this portion should be dark, this portion should be dark, and this edges should be dark, and above this this line, this line, and this line should be faint, because it we are imagining that this part of the solid is going to cut out. And again use the hatching line. Hatching line should be in 45 degree. Okay, it should be 45 degree. Okay, don't show these hidden lines, because in the section line we don't use the hidden line, so don't use this. So this is basically it is the edge behind this, that is 3 to C is edge is that, so it's shown by a hidden line, so don't use that hidden line here. So this completes give the dimension of this side 40, this 45 degree, and this height. Okay, and this completes your first problem. For second and third problem, stay tuned. I will upload the video soon. Thank you.